Students, shut up, sit down, or I'll squash you like the bugs you are. This is the Maxwell Theatre at the Cavendish Laboratory of Cambridge, not a discount Bucks night in Bruges. So straighten up, or I'll rearrange your lower intestines the way they did at Harrow in the late 60s. Now, I'm only here because those bureaucratic troglodytes down Job Search Plus have no interest in marvellous world of Thespianism. Is that a word? And they insisted I show up here and read this bloody nonsense on theoretical physics if I can expect to get this week's meagre ration of the dole. So once a bloody again, I'm stuck here reading physics instead of reciting Shakespeare. The indignity! I once was Othello, and my final monologue once induced a critic to leave the theatre. Now, that's real acting. Also, I should inform you that your latest professor of physics vanished up the Zambezi while hunting quarks or some such nonsense, and was probably devoured by a pack of hyenas. But never mind, he wasn't an actor, so no great loss. So, sit still, zip it, and act like Benedict Cumberbatch is about to take a crap on stage. Shall Copenhagen Interpretation of Quantum Mechanics. And believe me, you'll hear it all from someone who'd rather be performing Sir Toby Belch in Twelfth Night at the Finsbury Amateur Theatrical Society. Now then, the Copenhagen Interpretation. And do try to stay awake, or I'll set the rats on you. The Copenhagen Interpretation of Quantum Mechanics is where physics and philosophy meet for a perplexed cup of tea. Waves and particles politely ignore each other, and certainty sneaks off for a pint. It was born in the flamboyant 1920s, named after Copenhagen, a city famous for pastries and people furrowing their brows, and championed by Niels Bohr and Werner Heisenberg. Together, they dared to ask, what if reality was more of a suggestion than a rule? Bohr believed reality depended on context, or possibly his mood that morning, while Heisenberg's uncertainty principle chirped, you can't know everything about a particle. Want position? Forget velocity. Want velocity? Tough luck with position. Want both? Who do you think you are? A god of physics? They argued that nothing existed until it was measured, a claim as baffling as saying Copenhagen itself didn't exist until the tourists turned up. Naturally, this irritated Albert Einstein, who famously grumbled, God doesn't play dice with the universe. Quantum mechanics, ever the cheeky upstart, shot back, no, but he definitely enjoys a few rounds of poker where nobody knows the rules. And just like that, the debate escalated into a cosmic comedy routine. Einstein, ever the steadfast realist, couldn't fathom a universe that operated on probabilities and randomness. A true god, he declared, pacing his study dramatically, would play a game with clean, deterministic rules. Chess, perhaps, or maybe billiards. But dice? Ridiculous. Quantum mechanics, meanwhile, lounged in the corner, sipping a quantum martini, both shaken and stirred, and said, you're thinking too small, Al. God isn't playing a tidy little game of chess. He's running an interdimensional casino where every roll of the dice, flip of a card, and spin of the roulette wheel simultaneously exists and doesn't. And the house? Oh, it always wins. Einstein, unimpressed, countered, if this is a casino, then what are the odds anyone can actually understand it? Quantum mechanics smirked, about as good as measuring a particle's exact position and momentum at the same time. Einstein groaned, shaking his head. And what's with the spooky action at a distance nonsense? Are we seriously saying particles can communicate faster than light, like some sort of cosmic WhatsApp? Well, quantum mechanics said, leaning forward with a sly grin, it's not spooky if you think of it as God's way of keeping things interesting. What's a casino without a little telepathic blackjack? Einstein wasn't buying it. I still can't accept that reality itself depends on observation. Are you telling me the moon doesn't exist if no one's looking at it? Don't be silly, Al, said quantum mechanics, swirling its Schrodinger's drink. The moon exists. It just likes to play coy until you send a probe to measure it. Think of it as celestial hard to get. And this randomness you insist on? Einstein pressed. Do you expect me to believe the entire universe runs on some sort of cosmic luck? Quantum mechanics grinned like a Cheshire cat. Luck? Oh no, my dear Albert, it's not luck, it's probabilities. Luck is for amateurs. This is professional chaos. Einstein threw up his hands. Fine, but one day we'll discover the hidden variables, and your precious randomness will turn out to be an illusion. It'll be as deterministic as a train timetable. Quantum mechanics laughed, a sound like 1,000 collapsing wave functions. Hidden variables? Oh, Albert, if they exist, they're hiding better than my socks after laundry day. But if you find them, do let me know. I'll be at the poker table with God. Einstein muttered something about the universe being a terrible card player and left, while quantum mechanics resumed its game of Schrödinger's solitaire, where every card was both face up and face down until you looked. Before quantum mechanics got its act together, there was the old quantum theory, which was a bit like trying to build a spaceship out of wet spaghetti and sheer optimism. Max Planck, quantum mechanics' reluctant founding father, grumbled something like, "Let's call it a quantum and hope no one notices we're making this up as we go." Somehow, this haphazard approach birthed the Copenhagen Interpretation, which declared, stop worrying about what's real and just calculate the odds. Also, don't forget to admire the pastries. At the heart of the Copenhagen Interpretation lies wave-particle duality, which is like trying to decide if a light beam is a wave crashing at a beach party or a particle attending a quantum book club. Bohr, ever the philosopher-physicist, declared, "It depends on your perspective," a statement equally applicable to quantum experiments, art critiques, and whether pineapple belongs on pizza. Light, apparently, is the ultimate people-pleaser, adapting its behavior to match your experimental vibe. Shine it through a double slit, and it spreads out like it's auditioning for a surfing competition. Try to catch it red-handed, and it tightens up, masquerading as a respectable particle. Max Born, always keen to inject a bit of mathematical razzle-dazzle, proposed squaring the wave function to get probabilities, which made about as much intuitive sense as squaring the number of cats in Schrödinger's box. This little trick, however, allowed physicists to calculate the likelihood of particles showing up in specific places, transforming quantum physics from abstract musings to a high-stakes guessing game. Sure, it still didn't explain why light couldn't just pick a personality and stick to it, but at least the equation's fabulous. Einstein, watching all this from the sidelines, raised an eyebrow. "So," he muttered, "light is both a wave and a particle. That's like claiming to be both early and late to a meeting. Utter nonsense." But quantum mechanics, already lounging smugly in its probabilistic hammock, simply winked and said, "It's not nonsense, Al, it's superposition." In practice, wave-particle duality meant that every experiment felt like playing a cosmic version of Where's Waldo? But with Waldo constantly changing outfits and locations just to mess with you, and somehow, instead of providing answers, it left everyone more confused. Bohr, however, was unperturbed. "The beauty of it," he said with a twinkle in his eye, "is that it keeps us on our toes. Or possibly on our collective last nerve. Then there's wave function collapse, which is basically quantum mechanics doing its best magic trick, a sleight of hand Houdini himself might have admired. Before you measure something, it exists as a hazy cloud of possibilities, a quantum cocktail of maybes and might-bes, much like your plans for Friday night, a movie, drinks, a spontaneous decision to start a knitting club. The universe hasn't made up its mind yet. But the moment you measure, poof, one definitive outcome appears, and all the other options vanish into the ether, leaving you to wonder if they were ever truly real or just cosmic placeholders. Bohr, of course, insisted this wasn't an actual collapse, no dramatic implosions or flashy pyrotechnics. It's purely mathematical, he reassured, though to skeptics it sounded an awful lot like physics, shoving all those unrealized outcomes under a cosmic rug and whistling innocently. Imagine a waiter presenting you with a menu of infinite possibilities, only to snatch it away the moment you glance at it, saying, "Surprise! You're having the soup." Einstein naturally couldn't abide this. "Are you telling me the universe just decides when we look? What is it? Shy?" Bohr responded with his usual cryptic charm. "Not shy, Albert, merely enigmatic." This explanation satisfied precisely no one, though Bohr did receive a standing invitation to join every philosophy club in existence. And what about all those unchosen possibilities? Where do they go? Are they filed away in some quantum lost and found, or do they dissipate like the faint smell of toast you're convinced doesn't exist? Physicists still debate this, though some suspect they escape to parallel universes where every absurd what-if actually happens. In one, you're a Nobel-winning tap dancer. In another, Schrödinger's cat has its own reality TV show. Meanwhile, the idea of wave function collapse continues to baffle and delight in equal measure. To the untrained eye, it's a perplexing bit of cosmic choreography, where reality pirouettes into being just in time for the spotlight. To physicists, it's proof that the universe is a drama queen, constantly reinventing itself for its one-woman show. As for the rest of us, we're left applauding, wondering how the trick was done, and secretly hoping the universe's next act involves fewer paradoxes and more snacks. Meanwhile, Werner Heisenberg described this process as reduction, which made it sound like a recipe. Bohr, ever the philosopher, claimed the collapse didn't really matter. It's the vibes of the experiment that count. Naturally, this didn't sit well with Einstein, who may or may not have thrown his hat on the ground and shouted, "Do you believe the moon isn't there when you're not looking at it?" Bohr might have quipped, "The moon's always there. Albert, it's just really good at pretending." The Heisenberg cut added even more intrigue, raising the question, where does the quantum world stop and the classical world begin? Heisenberg thought a clean line was needed. Bohr shrugged and said, "Why bother? Reality's fuzzy like a bad photo or a missed haircut appointment." Later, critics like John Bell dismissed this boundary as the shifty split, proving that physicists are terrible at naming things. Einstein kept up his crusade against quantum randomness with the EPR paradox, accusing quantum mechanics of endorsing spooky action at a distance. Quantum mechanics, thoroughly unbothered, smirked and said, "Yes, but the spooky kind is so much fun." Experiments later confirmed this spooky action, leaving Bohr looking smug and Einstein muttering, "The universe is trolling me." Schrödinger's cat, which I discussed in a previous lecture, and if you didn't attend, then you have bugger all chance of passing out this year. Schrödinger's cat became quantum mechanics' unofficial mascot, embodying its gleeful absurdity. Picture a cat in a box, alive and dead simultaneously, because quantum physics doesn't care about your binary thinking. Schrödinger invented the thought experiment to mock the Copenhagen Interpretation, but it only made physicists love it more. Meanwhile, Wigner's friend added another layer of nonsense by suggesting someone could observe the cat and still be in quantum limbo, because why not? In the end, the Copenhagen Interpretation not uncovering what is, but embracing what works without plunging into existential dread. It's a practical shrug of good enough, paving the way for alternatives like the many worlds interpretation, where every quantum decision spawns a new universe, or Bohmian mechanics, a steadfast holdout for determinism beneath quantum chaos. These interpretations remind us that quantum mechanics is less a solution and more an endless conversation, a debate about reality's nature and our place within it. The Copenhagen Interpretation may not answer everything, but it gave us a foothold, inspiring us to keep questioning, exploring, and dreaming of what lies beyond. And so you regurgitated bags of old phlegm. Today's reading of the Copenhagen Interpretation here at the Maxwell Lecture Theatre at the Cavendish Laboratory comes to a close, although I'm sure you have gained little beyond developing calluses on your arses, and an understanding of absolutely bloody nothing about absolutely bloody nothing. But at least you heard me speak. Ah, science at its best. Note all this without once ranting about Benedict Cumberbatch, and speaking of my arch-nemesis. Did you know that Cumberbatch has declared me persona non grata at the Old Vic? All because I had the temerity to suggest he was taking up the entire stage with his acerbic rendition of Hamlet. To which I replied, he is damnatio memoriae to me. And if you remember, your Latin in Form 6 at Harrow means he is damned forever in my memory. At which point 2 of the tea ladies dragged me out the back and took turns beating me to a pulp with a broom handle. Outrageous! I was simply telling the truth. His rendition really was acerbic. Now you sloth-like bandicoots! You can crawl back to whatever rat holes you emerged from this morning in your usual crepuscular forms, and please never attend my readings ever again. You really do smell like old cabbage.